Let's derive the quotient trig identities. So here they're called the tangent and cotangent identities, but more officially these are called the quotient identities. You'll see on other trig identity sheets they'll be labeled the quotient identities. So that's tangent theta is equal to sine theta over cosine theta, and cotangent theta is equal to cosine theta over sine theta. Now, in the previous video, when we derived the Pythagorean identities, we started by writing out the trig function definitions based on the most general definition. You have an xy coordinate system. You can think about any angle theta in the plane measured from the standard position. So the initial side is along the positive x-axis and positive angles are counterclockwise. So you can think about any angle theta. No matter what the angle, you could create a right triangle like this. You pick a point along the line that the angle theta creates. That's the end point is at the origin and the line extends out to infinity. You pick any point and you create a right triangle to where the right angle is connected to the horizontal axis. And so with that, the hypotenuse of the right triangle is r. It's always positive. And the legs are the x, y coordinates of the point. And these x, y coordinates can be positive or negative. They obey the, they're just based on the coordinate system, the x coordinates and the y coordinates. And so with this definition here, then you proceed to define the trig functions like this. And so where the quotient identities come from, you can think about it's just playing with these, dividing different trig functions to see which result in like a clean form or result in another trig function. And so if you divide sine theta and cosine theta, you get tangent theta. But since cotangent is just the reciprocal of tangent, then cotangent is the reciprocal of this, which is cosine theta over sine theta. And so that's the quotient identities. Now, you might be wondering, well, why aren't there other quotient identities? I'm sure we could play with this and divide different trig functions and see what happens. Well, the reason is because, okay, for example, let's divide tangent theta by secant theta. Y over r is equal to sine theta. So why isn't this a quotient identity? Sine theta is equal to tangent theta over secant theta. Well, because with the reciprocal identity, so, sine theta is 1 over cosecant theta, etc., you can start here with either of these two and easily get to something like this. For example, let's start with this quotient identity. Let's multiply both sides by cosine theta. But we can change cosine theta to 1 over secant theta. And there we go. So these are the only official quotient identities. Any other quotient relationship between the trig functions can easily be derived from starting with either one of these two.